In the last video, we crafted a program that enables you to enter a certain word or text into a program, and that program will automatically return that text to you. Now, as you can see, I've added a few extra lines of code. This is called a condition, and that's what this video and the next one is going to be all about. In these two videos, we're going to be talking about decision making in C++, the kind that where if certain conditions are met, then your program will be able to execute a certain set of specific instructions. This first video will cover if statements, if and else if statements, else statements, as well as flags. Right away, let's go ahead and initialize the program. What if I were to enter anything other than the word in this condition? For example, ha ha ha. The program will just exit and not do anything. Because this specific condition wasn't met, the program will just go to another set of if statements. But since there isn't any other condition to fulfill, the program doesn't know what to do, and hence just moves to this line of code over here, which tells the program to end and return with a value of 0. That is what you have just seen. Now, what if I were to just meet the specific instruction? Of course, if I tell it exactly what I want it to do, which in this case is input the word Sunny and give me this set of instructions, then of course it would do that. Now, as you can see, I've used the relational operator equals. You might ask me, oh, can I use other relational operators? Of course you can. I've created a separate program over here which gives you a grade based on how many marks you have obtained for a test. Now, two things you might notice here. One is I have written the bigger numbers first, and the reason for that is C++ always reads your code from top to bottom. So I've given it the condition that if my grade is more than 90, then it were to say that I have obtained a grade of A+. Then it would carry on its specific order and carry on to the next instruction. If the number is not more than or equal to 90, then it will go on to the next one, which is more than or equal to 80. If this is the case and this condition is met, then it will output the instructions I just gave it. The second thing you might notice is I have written a bunch of if statements one after the other, and you might think, yeah, this is correct, right? I mean, it's conditions, and you just said that C++ reads code from top to bottom, so logically, it will execute the first instruction based on the condition met, correct? Wrong. This is where else if statements come in. Right away, I'm just going to execute this code with if statements. If I choose, let's say, I got 98 marks, it's going to output the instructions based on the conditions that I've specified throughout this program. The reason for this is because 98, according to C++, yes is more than or equal to 90, yes is more than or equal to 80, and yes is more than or equal to 70. So since all three of these conditions are met, it's just going to go ahead and give all the prompts in one big block. To stop this from happening, we are going to make use of the else if statement. And notice the difference. Look at the difference these two simple words make. Let's say if I were to obtain a grade of 87, which would be an A, it just satisfies this one condition and only executes this line of instructions. So instead of the program looking at all of the conditions, and let's say if the value I input meets all of them, then it will follow all the instructions. It's just going to take a look at one of the conditions that are met. So 89 is not more than or equal to 90. So of course it will go on to the next instruction. It's more than or equal to 80, and it would just do as it's instructed to. However, since I have put else if for this condition, it will automatically void this line of code over here, which is else if grade is more than or equal to 70. This explains why it doesn't put your grade is A and your grade is A minus at the same time, as we saw previously if we just use if. This is what else if statements are for. So straight away, it just voids this line because it's already met one condition. C++ says, oh, you've met this condition. I've done what you want me to do. All right, all the other else ifs are void. Let's go ahead and execute the next line of code, which is return 0. And of course, as always, we have closed that line of code with an initializer semicolon. I would also like to add something that I have hilariously forgotten to point out this entire tutorial series, which is that you can actually add texts that have nothing to do with the program, just as labels for you as a normal human being to read. But C++ doesn't make use of those lines. So for example, if I want to label this as instructions for if my mark is more than or 90, C++ will see this and ignore it. But you as a human will be able to see it and know that amongst your entire block of code that you've written for, let's say 100 or 200 lines, oh, this is where I need to go to. If let's say I've encountered an error, I need to go back here and I know where to find it again. This is known as a comment. And the basic format for it is 2 slashes with the pointy end at the bottom facing to the left. So just to recap, we have learned about if statements, we've learned about else if statements. The general format for these two is the same. You write your condition in double brackets, you close it out with a curly bracket, and you write whatever instructions you want to give your program between the curly braces. Else if is the same thing. And the list goes on. Now, of course, you might be asking, hey, I can just be cheeky and put in a negative value, right? So you, as a programmer, you want to enter a line of code that deters these cheeky people from using your code. So let's say if none of these conditions are met, we can go ahead and type one last line. This is after we have declared all of our conditions. Our program is working flawlessly. Now we just want to eliminate invalid user inputs. And for that, we are just going to enter as the last line in this chain of conditions, else. Straight away followed by curly braces. That is the basic format, nothing more, nothing less. So let's say other than these numbers, let's say I've already carried out all these instructions and people just want to horse around, you know, enter something outside of these values. I can put cout, that is not a valid input. Let's say if your teacher says that failure is not an option, you absolutely have to get an A-. If someone else goes and puts a mark, let's say 69 or 54, anything below or outside of these conditions, then in the end, the program has one last line of code to fall back on. And that's what the else statement is for. This last line of code, which involves the else statement, is known as a trailing else and is most commonly used, as I mentioned earlier, to validate invalid user inputs and to carry out a specific set of instructions based on that last condition if it doesn't meet any other of the requirements over at the top here, the ones that you gave your program. However, the else statement also has other uses other than just trailing elses. It can also be used when you're in a scenario where there's only one condition and it's either true or false. In this case, I redesigned my program to give me a set of statements based on the grade I have obtained. If my grade is more than or equal to 90, then it will tell me that my grade is an A+. And since it is not less than or equal to 50, the program will also tell me, lucky you. However, if I enter a value that's outside of this condition, let's say 76, but it still fulfills this condition, it will then accomplish this set of instructions followed by this set of instructions. Lastly, if I were to enter something that fulfills both of these conditions, then it will execute both of these instructions. To prove my point, let's go ahead and run this program. So let's say I obtain a grade of 90. So my grade is A+, lucky me. 90 satisfies this condition, but doesn't satisfy this condition. So it goes ahead to the else statement and carries out the instruction there. What if I enter something that's outside of this condition, but also does not fulfill this condition? Let's say 76. Yep, failure is not an option. That's the instruction that it carries out if it's outside of that condition. But since my value is also outside of this condition, it goes ahead and goes to the other else statement as well. But what if it fulfills both conditions? Let's say 45. Failure is not an option, you failed. So as you can see, there's many possibilities. To recap, there's else statements as well. Else can either be used as a trailing else in order to eliminate invalid user input, or in this case, to carry out a set of instructions based on whether a condition is met or not. The last topic we are going to cover for today is flags. Now, what are flags? Flags are basically a preset condition which is always bool, so it's either true or false, that can be validated later throughout the program. This is extremely useful, and one of its uses is, as I said before, eliminating invalid user inputs. Not only can we make use of the else statement, but we can also make use of flags. So let me explain what I mean by this. I have entered a flag where I have declared a new variable as a bool, so valid grade. Valid grade, basically, I want this variable to determine whether this program proceeds to run or not. So I have identified it as true. So its value is 1 throughout. Unless something happens and I set a condition and the user enters a value that meets that condition, that will change the value of this flag. In this case, I want to make this program so that it does not accept negative inputs. I've entered an if statement that says that if my grade that I entered is less than 0, then that's going to be a problem. So it will automatically change this flag value to false. And if it's false, which is a 0, then my program will not run. On the other hand, if I enter a variable that doesn't meet this condition, nothing happens to the flag. It will just execute as normal. And through this statement that says if valid grade, so basically the flag is true, the value is 1, then it will execute the instruction. And grade mark, thank you for not being cheeky. Basically, you didn't input a negative number. So that's a flag. Basically, it's a bool variable. You declare one condition by default, and you can later use it throughout your program and change it as you please to suit your needs. As I've said many times before, the possibilities are endless. That's the end of part 1 of decision making with C++. I will see you in part 2. Thank you.